for thousands of years, one of the essential human elements is shelter. We've been trying to improve that shelter. And we've made huge gains, especially around the turn of this last century with cooling.
Refrigeration is part of our daily lives.
We have large strides that we still need to make. Part of those large strides are controlling the comfort in the space.
We've all been in uncomfortable spaces where you're sitting there freezing cold or too hot. The reason for that is that the velocity coming out of the registers and diffusers is way too high, and that's what's creating that draft.
Drafts can make a perfectly tempered building feel very uncomfortable. So a major key to integration is also including every aspect of velocity in that space as well.
With the high induction supply system, we're able to control the throw, and the idea is that we want to throw that air to a point in space where we're at a T50, meaning that the air is moving at that point in space at 50 feet per minute. We want that to be approximately 6 feet up from the floor in the space. The reason that that's important is because we don't want the occupants in that space to feel direct airflow physically on them, and then you're creating draft.
When you look at building comfort, you have to look at both temperature and humidity. Different humidity levels can make the same temperature feel much different. And what we know now is that traditional RTUs do not control humidity levels in the space. They try to by running the cooling a little longer, but we know that's not a good solution. The way DOAS can control humidity in the space is we use a very thick coil, and we force the air to interact with that coil more efficiently and for a longer period of time. It cools the air molecules down below its dew point and drops moisture out of the air. We actually warm the air back up after that to deliver it to the space in a comfortable range. Shoulder days are critically important because it may be cool outside but very humid. We can have huge swings in temperature and humidity in one day. The unit has to decide whether or not to heat or cool, and DOAS is the only way to really address these issues. If you've ever been sitting next to a door and someone opens the door and cold air rushes inside, that's because the building's under negative pressure. Positive building pressurization is key to making comfort work. When you have an exhaust load in a building, that air has got to come from somewhere. If you don't have enough positive pressure, it comes from every little nook and cranny and crack and crevice in the building. And that air is untempered. It's hot, humid, sometimes cold. So it's either going to come through the building envelope or it's going to come through the DOAS. And when it's introduced through the DOAS, we can control the exact temperatures, velocities, CFMs. We can control all those factors to make the outcomes perfect in these buildings.
I think humanity is always in pursuit of comfort, whether it's feeling comfortable in a space, whether it's the food we eat. And so, as we move forward, we need to be more aware of the space.
What if you never had to think about building comfort ever again? It's not something easy to explain, but it is a tangible thing. You're not focused on how cold you are, how hot you are. That's perfect comfort. When we integrate those products together, we can create a perfectly comfortable space where people don't even realize there's air moving around them. It's a better long-term solution.